Let's talk about finding a confidence interval for the mean when the population standard deviation sigma is unknown using a table. For example, construct a 95% confidence interval for the mean number of pets in the households of college students. Suppose that a sample of size 47 students yields sample mean x bar equals 1.40, sample standard deviation s sub x equals 1.50. Mind you, I did not make up these data. These are the results of a survey of my statistics students. We have way more than the average number of pets. We have 7 pets. We have 4 cats. There's Moose, Bean, Cupcake, Pumpkin. We also have 3 chickens. There's Sunny. Mei Li's in the back here. She's a silky. That's a Chinese breed, kind of fluffy. And there's Priscilla over here. Okay, so we're constructing 95% confidence interval for the mean number of pets in the households of college students. When the population standard deviation sigma is unknown, the endpoints of a confidence interval are x bar plus or minus t sub alpha over 2 s over square root n. Notice that unlike before, this is not z sub alpha over 2, it's t sub alpha over 2. So we don't know the population standard deviation, use the t distribution instead of the normal distribution. The only difference is that the t distribution is a little bit fatter in the tails, so this interval is going to be a little wider than the corresponding 95% confidence interval that would be based on the normal distribution. Okay, so let's look at the t-distribution table. We can find it in the textbook. It's in a table in the appendix of our textbook. This is the textbook we're using. For that, you'd go to MyLab Statistics, Pearson eText, then choose Table of Contents and Appendices. If you have an electronic textbook, I'm sure you can find it in the same way. Or you could just enter t-distribution table into a search engine. Either way, you're going to get a table that looks like this. So Table 5, t-distribution. And here's how to use such a table. So first we look at the column. We have a two-tail probability of 0.05. That means the significance level alpha is 0.05. That's because we have a 95% confidence interval. So what's left over is 5% or 0.05. Okay, 2 tails, 5%, 0.05. This is the column we want. The row, for the row, we look at the df, degrees of freedom. That's simply n minus 1. Here n is 47, so n minus 1 is going to be 47 minus 1, which is 46. And we always round down, so we want 45. Even if we had 49 degrees of freedom, we would not round up to 50. We always round down with degrees of freedom. So we want this row. So it looks like we want 2.014. That's t sub 0.025. Okay, let's plug in everything. So x bar is 1.40. T sub alpha over 2 is 2.014. S, the standard deviation, is 1.50. And the square root of n is 47. So it looks like our 95% confidence interval, when you calculate this, is 0.959 to 1.84. Now let's construct a 90% confidence interval. Everything's going to be the same, okay? Same formula, x bar plus or minus t sub alpha over 2 s over square root n. X bar is the same, standard deviation is the same, n is the same. The only difference is that we need a different t. Okay, so now we're going to use a different column. The two-tail probability is 0.10, so we want this column because it's a 90% confidence interval, so what's left over is 10% or 0.10. 0.10 is also called the significance level. It's alpha. The row, that's going to be n minus 1. It's degrees of freedom. It's 47 minus 1, which is 46. Again, we round down to 45. So it looks like we want 1.679. So it's t sub 0.05. Okay, so let's plug everything in. X bar 1.40. T sub alpha over 2 is now 1.679. Sample standard deviation 1.50. Square root of n is root 47. So the 90% confidence interval, once you calculate all of this, turns out to be 1.03 to 1.77.